Hello students, welcome to this lecture 1 Arithmetic Progression. In this lecture we'll study the revision and sum of first n terms of an AP. Okay, so first we will revise whatever covered in our previous lecture. Okay, and then we'll discuss a new topic, sum of first n terms of an arithmetic progression. Okay, so let's get started. So in our previous lecture we have studied an arithmetic progressions about arithmetic progressions. Okay, so what is arithmetic progression? An arithmetic progressions AP is a list of numbers in which each term is obtained by adding a fixed number d to the preceding term. Okay, so except the first term and the first number d and the fixed number d is called the common difference. So what is basically an arithmetic progression? So an arithmetic progression is a list of numbers in which term is obtained by adding a fixed number d to the preceding term, except the first term, and the fixed number d is called the common difference. Okay, and we also have studied the general form of an arithmetic progression, that is a comma a plus d comma a plus 2d comma a plus d comma dot dot dot. Okay, so this is the general form of an AP, where where A is first term and the D is common difference of this AP. Now, next point, a given list of numbers A1, A2, A3, dot 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 is an AP if the difference A2 minus A1, A3 minus A2, A4 minus A3, and dot 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 give the same value. Okay, the same value. That is AK plus 1 minus AK. This is the same for different values of K. Okay, so we have a given list of numbers A1, A2, A3, dot dot dot, and this list of numbers is an AP. And if the difference A2 minus A1, A3 minus A2, A4 minus A3, and dot 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 give the same value, that is if AK plus 1 minus AK is the same for different values of K. Okay, then this list of number is an AP. And in third point, we have studied in an arithmetic progressions with first term A and the common difference D. The nth term or the general term given by an is equal to a plus n minus 1 times common difference D. Okay, so an is equal to a plus minus 1 times D. And here let us consider the situation for clearing the concept sum of first n terms of an AP. Okay, so here we first introduce sum of first n terms of an AP by taking this example. Here we consider this situation. Sakila put 100 rupees into her daughter's money box. When she was 1 year old, rupees 150 won her second birthday and rupees 200 won her third birthday. Okay, and will continue in the same way. How much money will be collected in the money box by the time her daughter is 21 years old? Okay, so in this example, basically we consider this situation. Sakila put 100 rupees her daughter's money box when she was 1 old. Okay, when she was 2 years old, that means her second birthday, she puts 150 rupees and she puts two, 200 rupees on her third birthday and continue this process. Okay, so now question is how much money will be collected in the money box by the time her daughter is 21 years old. Okay, that means here you have to find her 21st birthday. How much money will be collected in the money box? Okay, so let us see how to solve this. Here the amount of money in rupees put in the money box on her first, second, third, fourth, and birthday were respectively 100, 150, 200, 250, till her 21st birthday. Okay, so to find the total amount in the money box on her 21st birthday, we will have to write each of the 21 21 numbers in the list above and then add them up. Don't you think it would be a tedious and time consuming process? Okay, so don't you think it would be a tedious and time consuming process? Okay, so can we make the process shorter? Okay, now our questions. Can we make this process shorter? This would be possible if we can find a method for getting this sum. Okay, so now our motive is finding a method for getting this sum. Okay, so let us see. We consider the problem given to those to solve when he was just 10 years old. Okay, actually, his teacher gave uh, gave to him a problem for finding sum of positive integers from 1 to 100. Okay, so he was asked to find the sum of positive integers from 1 to 100, and he immediately replied that the sum is 5050. So basically, how he replied the sum of positive integers from 1 to 100 is 5050. Can you guess how did he do? Okay, basically he do this process. He wrote positive integers from 1 to 100 and add them. Okay, so he wrote s is equal to 1 plus 2 plus 3 plus 4 plus plus 9 plus 100. Okay, and then wisely he reversed the number to right. Okay, and he also wrote these numbers in the reverse way. Okay, so s is equal to 100 plus 99 plus 98 plus 97 plus 96 plus plus 3 plus 1. Okay, so here basically after reversing the numbers, we get s is equal to 100 plus 99 plus 98 plus plus 3 plus 1, 2 plus 1. Okay, then adding these two, then we get in left hand side 2 times s. Okay, and in right hand side we will get 100 plus 1 plus 99 plus plus 3 plus 98 plus 2 plus 99 plus 1 plus 100. Okay, and if we take this pair and add them, then we'll get 101 each time. Okay, so 101 plus 101 plus 101 plus plus 101, and this is actually 100 times. Okay, so 101 added here 100 times. So 2s basically is equal to 100 times 101. Okay, and s this is equal to 100 times 101 divided by 2. And if we calculate it, then you will get this is equal to 5050. That is the sum is equal to 5050. Okay, so the sum of positive integers from 1 to 100, that is equal to 5050. Now we'll use the same technique to find the sum of the first n terms of an arithmetic progression. Okay, So if we know the general form of an arithmetic progression is a comma a plus d comma a plus 2d plus comma a plus 3d comma dot dot dot. Okay, so this is a general form of an AP whose first term is given by A and the common difference is given by D. And then the nth term of this AP is basically first term A plus number of terms n minus 1 times common difference D. Okay, so here we let here S denote the sum of the first n terms of this AP. So we have S is equal to A plus D plus A plus 2D plus dot 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 plus A plus 8 minus 1 times D. Now if we rewrite these terms in the reverse order, then we have S is equal to A plus n minus 1 times D plus A plus n minus 2 times D plus dot 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 plus A plus D plus A. Okay. Plus A. And we one adding 1 and 2. So this is 1, this is 1 and this is 2. Okay. So now if we adding 1 and 2 term wise. Okay, so if we add them term wise, then we get 2 times S. This is equal to 2A plus n minus 1 times D plus 2A plus n minus 1 times D plus dot 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 plus 2A plus n minus 1 times D. And this is actually n times. Okay, so we added 2A plus n minus 1 times D n times. For 2 times S, this is equal to n times 2A plus n minus 1 times D. And that is S is equal to n by 2 times 2A plus n minus 1 times common difference D. So the sum of the first n terms of an AP is given by S is equal to n by 2 times 2A plus n minus 1 times common difference D. So here we get this formula, the sum of first n terms of an AP. This is equal to S is equal to n by 2 times 2A plus n minus 1 times common difference T, where n is the number of terms in an AP and A is first term of this AP and the D is common difference of this AP. Okay. So we can also write this as S is equal to n by 2 times A plus n minus 1 times D. And we know that an, this is equal to A plus n minus 1 times D. Okay. So we know this and we can write S is equal to n by 2 times A plus an. Okay. Now, if there are only n terms in an AP, then the nth term an basically the last term. Okay, so an is equal to L, the last term. So from 3, this is our 3, equation number 3. Okay, so now question number 3, we see that S is equal to n by 2 times first term A plus last term L. Okay, so S is equal to n by 2 times A plus L. This form of the result is useful when the first and last term of an AP are given. Okay, so we get in last, we get this formula for sum of first n terms of an AP, that is S is equal to n by 2 times first term A plus last term L. And this formula basically will useful when the first and the last terms of an AP are given and common difference is not given. Okay, so now we return to the question that was posed. It posed to us in the beginning. Okay, that is the amount of money in rupees in the money box of Sakila's daughter won first, second, third, fourth birthday, comma dot dot dot, where 100, 150, 200 250 and comma dot 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 respectively. So this is an AP. So we have to find the total money collected on her 21st birthday. That is a sum of the first 20 terms of an AP. Okay, so of this AP. So here we can use the previous formula that actually was sum of first n terms is n. This is equal to number of terms n divided by 2 times first term a plus number of terms n minus 1 times common difference d. Okay, so here we have a is equal to 100, common difference d is equal to 50, and the value of n is equal to 21. And using the formula S is equal to n by 2 times a plus n minus 1 times d, we have here S is equal to 21 by 2 times 2 into 100 plus 21 minus 1 times 50. That is equal to 21 by 2 times 200 plus 1000. And this is equal to 21 by 2 into 100, 1200, that is equal to 12,600. Okay, so the sum S is equal to 12,600. So the amount of money collected on her 21st birthday is 12,600. Okay, now has not the use of the formula made it much easier to solve the problem. So now this formula actually made much easier to solve any problem related to sum of first n terms of an AP. Okay, so we also use Sn in place of S to denote the sum of first n terms of an AP. Okay, so we write S20. This is to denote the sum of the first 20 terms of an AP. And the formula for the sum of the first n terms involves 4 quantities that are S, first term A, common difference D, and the number of terms N. Okay, so if we know any three of them, okay, then we can find the fourth one. So we get basically here the formula for the first n terms of an AP is n. This is equal to n by 2 times 2a plus n minus 1 times d. And in this formula involves 4 quantities that are S, A, D, and N. Okay, and here if we know any 3 of them, then we can find the fourth. Now here one remark is the innate term of an AP is the difference of sum to first n terms and the sum to first n minus 1 terms of it. That is an, this is equal to Sn minus 1. Okay, so an, this is equal to Sn minus 1. Now clearing this topic, here we explore some examples. Okay, so let us consider some examples. In this example, we have to find the sum of first 20 terms of the AP 8, 3, minus 2, dot dot dot. Okay, so here we have to find the sum of first 22 terms. So here we have given the value of A is equal to 8 and the common difference D. This is equal to 3 minus 8. That is equal to minus 5. Okay, and the value of N is equal to 22. And we know this formula S is equal to N by 2 times A plus N minus 1 times common difference D. And here we have given these values, and now if we put these values in this formula, then therefore S is equal to 22 by 2 times 16 plus 21 times minus 5. And if we calculate it, then we'll get this is equal to 11 times 16 minus 105, and this is equal to 11 times minus 9, that is equal to minus 979. Therefore So the sum of first 20 term of the AP is minus 9979. Okay. So using this formula, we we found the sum of first 20 terms of given AP, that is equal to minus 979. Okay. Now here in this example, we have given if the sum of the first 14 terms of an AP is 1050. Okay, and the first term is 10. Find the 20th term. So where we have given the first 14 terms of this AP, that is 1050, and its first term is 10, that is given. Okay, then we have to find the 20th term of this AP. Okay, so let us solve this problem. So here S14 that is given to us is equal to 1050. Okay, and the value of n is equal to 14. The first term a is equal to 10. And as we know the formula Sn, this is equal to Sn is equal to n by 2 times 2a plus n minus 1 times common difference d. So here the sum of first 14 terms is equal to 1050. So 1050, this is equal to 14 by 2 times first term, that is a is equal to 10. So 2a times a plus 14 minus 1, that is 13 times common difference d. Okay, and if you simplify this, then you will get this is equal to 10140 plus 91 d. Okay, and that is 910, this is equal to 91 d, or d is equal to 10. Therefore a20, this is equal to 10 plus 20 minus 1 times 10, that is equal to 200. Okay, so the 20th term of this AP is 200, and this is our final answer. Now let us move to next example. So in this example here we have asked how many terms of the AP 24, 21, 18, dot 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 must be taken so that their sum is 78. Okay, so in this example we have to find how many terms of this AP must be taken so that their sum is 78. So here we have given a is equal to 24 and the common difference d, this is equal to 21 minus 24, that is equal to minus 3, and we let the number of n terms, sum of number of n terms Sn, this is equal to 78, and we need to find the value of n, and we know that the sum of first n terms of this of an AP is n. This is equal to n by 2 times 2a plus n minus 1 times common difference d. Okay, so here we consider Sn, this is equal to 78. So 78, this is equal to n by 2 times 48 plus n minus 1 times minus 3, and this is equal to n by 2 times 51 minus 3n. For we get this quadratic equation in variable n, 3n square minus 51n plus 156 equal to 0, or n square minus 17n plus 52 is equal to 0. And if we now factorize this quadratic polynomial n square minus 17n plus 52, then we get these two linear factors n minus 4 and n minus 13. Okay, so n square minus 17n plus 52, this is equal to 0, or n minus 4 times n minus 3 n minus 13, that is equal to 0, for the value of n are 4 and 13. Okay, so both values n are divisible, so the number of terms is either 4 or 13. Okay, so the number of terms is either 4 or 13 for this AP. The sum of these numbers is equal to 78. Okay, now here we give some remarks. in first one, in this case, sum of first four terms, this is equal to sum of the first 13 terms. This is equal to 78. Okay, so this is our first remark. And the second remark, two answers are possible. Okay, because the sum of the terms from 5 to 13 will be 0. Okay, so sum of the terms 5 to 5 to 13 will be 0, and this is because A is positive and D is negative. Okay, so that some terms will be positive and some others negative and will cancel out each other. Okay, so this is happen because A is positive and D is negative. So that some terms will some terms will be positive and some terms will be negative and will cancel out each other. And now here, next example, here we have to find the sum of the first 1000 positive integers, and second one we have to find the sum of first n positive integers. Okay, so let us solve this example. So here for first one, here we let s is equal to 1 plus 2 plus 3 plus dot 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 plus 1000. Okay, and here we using the formula Sn. This is equal to n by 2 times first term A plus last term L for the first n terms of an AP. And we have here n S 1000, that is equal to 1000 by 2 into 1 plus 1000, that is equal to 500 plus 1001. And if we multiply them, then we get this is equal to 500,500. Okay, so the sum of first 1000 positive integers is 500,500. And now for second one, here we let Sn. This is equal to 1 plus 2 plus 3 plus 4 plus dot 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 plus n. Okay, and here the first term A is equal to 1 and the last term L is n. Okay, so therefore we know the formula is n. This is equal to n by 2 times first term A plus last term L. Okay, so now if we use this formula, then we get the value of Sn. This is equal to n times 1 plus n by 2. That is Sn is equal to n times n plus 1 by 2. So the sum of first n positive integers is given by Sn. This is equal to n times n plus 1 by 2. Okay. Now we can easily find any sum of any first n terms of an AP by using this formula, that is Sn is equal to n times n plus 1 by 2. Okay. So if you now ask to find the sum of first positive integers of 2000 terms, that case you can find the sum of first 2000 positive integers. Okay, that is equal to s 2000, that is equal to 2000 into 2000 plus 1 plus 2001 by 2, that is equal to 1000 into 1001. Okay, now here in this example we have to find the sum of first 24 terms of the list of numbers whose nth term is given by an. This is equal to 3 plus 2n. Okay, so here we in this example we have given the nth term an. This is equal to 3 plus 2n. Okay, and as we know an, this is equal to 3 plus 2n. So first term an, a1, this is equal to 3 plus 2, that is equal to 5. And second term a2, this is equal to 3 plus 2 into 2, that is equal to 7. Okay, and the third term a3, this is equal to 3 plus 2 times 3, that is equal to 9. Okay, and list of numbers become 5, 7, 9, 11, dot dot dot. So here 7 minus 5, this is equal to 9 minus 7, that is equal to 11 minus 9, equal to 2, and so on. And so it forms an arithmetic progression with common difference d is equal to 2. So to find S24, we have n is equal to 24, a is equal to 5, and d is equal to 2. Therefore, S24, this is equal to 24 divided by 2 times 2 times 5 plus 24 minus 1 times 2. And this is equal to 12 into 10 plus 46, that is equal to 672. So, sum of first 24 terms of the list of numbers is 672. I stop here this lecture. Thank you very much to all of you.